The universe is under no obligation to make sense to us. On one side of this world, the sun never sets. On the other, it never rises at all. And between them lies a sea that glows gold all day, every day, forever. Something is moving through that sea. 3 out of every 4 stars in the sky are stars just like this one. This is the most common kind of planet in the galaxy, and it might also be one of the strangest places life could call home. Near a small red star, a sunrise is happening right now, and it will never end. On this world, morning arrived once, a very long time ago, and it simply never left. You already know a world that behaves this way, because it orbits you tonight. The moon always shows Earth the same face, locked in place by gravity. Now imagine moving a planet close enough to a small, dim star that the same thing happens to it. Gravity stops the whole world from turning, and once that happens, the day never changes again. 75% of all the stars in our galaxy are small, cool red dwarfs like this one. So a planet locked like this isn't some rare exception. It could be the most ordinary kind of world there is. For a long time, scientists assumed the answer was simple. Nothing good could survive there. But being locked in place is not the same as being lifeless. A spinning planet has day and night everywhere. A locked planet only has one border that matters, the line where its endless day meets its endless night. The nearest such world we know, Proxima Centauri b, is 4.24 light-years away. Even walking non-stop, the journey there would take about 300,000 years. Nearby, the TRAPPIST-1 system holds 7 Earth-sized planets, and 3 of them, E, F, and G, sit inside the star's habitable zone. Scientists have started asking whether these planets could hold on to an atmosphere. An atmosphere around these tidally locked planets could allow for energy transfer between day and night. If that's true, the atmosphere wouldn't just sit there. It would carry heat from the burning side of the planet to the frozen one. That one idea is the reason this story doesn't end with a dead world. So before deciding anything, let's go and see the burning side for ourselves. Step onto the day side of this world, and the sky isn't blue. It's a wall of light. The star never moves, never dims, never sets. It just stays there, enormous and close. From a world like TRAPPIST-1e, the star spans 2.17 degrees of sky, 4 times more than our sun fills from Earth. A single, oversized eye fixed directly overhead, forever. Noon has lasted here since the day this planet was born. There are no clouds to soften it and no night to interrupt it, so water can't survive on this surface. Whatever was here boiled away long ago. Nothing especially bad about tidal locking. The dayside can still be a perfectly good habitat, But a good habitat depends on one thing: whether the planet has an atmosphere thick enough to move that heat around. This brightness map compares a nearby sister world's day side to its night side. The day side reaches almost 200 degrees Celsius. The night side drops past 200 below. That's a 400-degree cliff with nothing in between to soften the fall. So the real question isn't whether this world is alive. It's whether it even has air at all. On Earth, the Atacama Desert is one of the driest places alive, and something still survives there, hidden in the smallest trace of moisture. If anything endures on a dayside like this, it will be small and hidden, tucked into whatever shadow the light hasn't reached yet. This isn't a garden, not yet. It's just a door left open a crack. Cross to the far side of the planet, and the light doesn't fade. It just stops. There's no dawn here, no glow, only a black sky filled with stars that never move. This half of the world has never once been warm. Temperatures fall past 100 degrees below freezing and keep falling from there. Sometimes the darkness isn't completely empty. A curtain of green light drifts across the pole, an aurora caused by the planet's magnetic field pushing back against the star's wind. The old assumption was that total cold meant total death. But under the ice, the story might not be finished. It might just be hidden. On Earth, Lake Vostok sits sealed beneath 2 miles of Antarctic ice, kept liquid by heat from below, and it holds life. If this planet holds even a little of its own internal heat, a hidden ocean could exist beneath the ice, sealed away from the cold above. Deep-sea vents on Earth prove something else. Sunlight was never the only fuel life needs. In total darkness, chemistry alone has already been enough, at least once, right here on our own planet. So the night side of this world might not be a grave, it might just be a sealed room with the lights turned off, but the heat still on. Neither side of this planet, the cooked one or the frozen one, is where its story actually lives. Between the fire and the ice runs a ring that never widens and never closes, a permanent twilight wrapped once around the entire planet. The light is gold, low and endless, neither day nor night, but one single frozen sunset circling the whole world. This is the line the entire story has been leading to. Even at this distance from its star, a planet here can still receive 60% of Earth's sunlight, more than half. Dim, but not dark. And unlike either hemisphere, the temperature stays steady here, mild and stable, for longer than Earth's oceans have existed. For a long time, no one could answer whether this ring could support life, because no one knew whether these planets even had atmospheres. In 2025, the James Webb Space Telescope looked straight through this planet's air as it crossed in front of its star. The result came back almost flat. No thick hydrogen, no heavy blanket of carbon dioxide. But a thick, swollen atmosphere was never what scientists were hoping to find here. A thin, Earth-like one is. These planets have all experienced the same stellar history because they orbit the same star, which means whatever survived on one of these worlds could plausibly survive on its neighbors too. Mercury has lost its atmosphere, but Earth and Venus clearly kept theirs. Right now, 3 planets in this system, E, F, and G, are still candidates for holding on to the same thing Earth managed to keep. Even the water itself might be more forgiving than Earth's own oceans. Salt lowers the freezing point of water. Water as salty as the saltiest sea on Earth can stay liquid down to nearly 19 degrees below freezing. And life on Earth has already been found active at 15 below. The twilight ring doesn't need Earth's exact conditions, it just needs to come close. That's not a hostile world. That's a laboratory that's been running the same experiment uninterrupted for longer than most stars even get to live. This is where we finally get to walk through the door the science just opened. Under a red star, ordinary green leaves wouldn't work very well. Most of this starlight arrives as deep red and infrared light, wavelengths green chlorophyll can barely use. But evolution has already solved this exact problem once, right here on Earth. A red-shifted pigment exists that lets living things capture near-infrared light directly. On a world lit mostly in red, that wouldn't be a strange exception. It would probably be the rule. This is the foundation the rest of the ecosystem stands on. Not green, but a deep, hungry red. And wherever a foundation like this exists, something eventually comes along to graze it. Nothing here needs to move quickly. In water this calm, speed simply isn't worth the energy it costs.
The dusk whale has never needed eyesight. In a world lit from one fixed direction forever, warmth tells it everything sight ever could. It has spent its entire life inside a single endless sunset. It has never once seen a sunrise, and it has never needed to.
Even microbial life alone would already make this a living world. A shallow, red-lit sea with something drifting through it is just this planet's own physics, taken seriously, all the way to its logical end.
Here's the detail that changes the shape of this entire question. A small red star like this one is expected to live for about 1 trillion years. Our own sun will only last about 10 billion years. A star like this could burn for 100 times longer. The sun is already halfway through its life.
A star like this one has barely even started. Long after Earth's oceans have boiled away in our dying sun's final swell, small red stars like this one will still be rising, fixed in exactly the same spot in the sky. We don't know exactly what could evolve given that much time. No model can reach that far with any real confidence. But we do know the coastline would still be there, and the sunset would still be holding.
So the very last light still burning in this galaxy one day might not come from a star like ours at all. It might come from a small red sun fixed forever on one horizon above a shoreline that's still holding its ground. A world doesn't need a sunrise to be a home. Sometimes all it needs is a horizon that never lets go.